Okay, welcome, Jacqueline and Betsy and Brenda and Bailey, and hopefully we'll have a few more come up soon. Let me tell you the plan today. Today's a big day, actually. What we're doing today is we're looking at hypothesis testing, which pretty much is what we're doing for the rest of this entire quarter, is hypothesis testing. So it's a major, major piece to cover. And so we'll talk about hypothesis testing. I'll give you some examples. And then after that, what we'll do is we'll talk about the midterm that's coming. So you must take the midterm by a week from Wednesday. And a week from Wednesday is the 29th of May. And late midterms are not okay. You need to take it on time, but you can take it early. In fact, a couple of you, I was a little surprised, are taking it kind of earlier than you probably should, but you're allowed to. Our earliest is in 2 days, which can happen, but it may not be the best idea. But none of you are that are here right now. So what I'll be doing is I'll talk about the midterm. I'll talk about some strategies for studying, some how you can practice, because practice is really what you want to do. Studying doesn't mean anything. It's really practice. And then kind of what the rules are of the midterm, what you can expect when you arrive and how it's going to work. So that's the plan of the day. Let me ask you, are there any questions about anything right now before I go on to hypothesis testing? And I will talk about the midterm in a little bit. Any questions at all? And also, if I go a little later than usual, then that could happen because we have two major things to talk about. Hypothesis testing is really important, and the midterm is also really important in terms of your grade. Okay, so let's see. If we take the midterm May 29th, but the proctor sends it on 30th, you must take it on the 29th. And usually the proctor sends it right away. You try and get them to send it right away. It's not that hard to send it. The proctor just takes a picture and emails it to me. It's really no big deal to send it. But if they have to, for some reason, send it on the 30th, that's fine. That's not your fault. But you need to take it by the 29th. That make sense, Charles? Okay. Any other questions? It's a good question. You know, logistical questions are important. Any other questions? Okay, if there's no questions, I think I want to talk about hypothesis testing. And I want to mention that you've done this before. You haven't done the mathematics of it, but you actually do it in, I think, 8th grade science. And I'm sure you remember everything about your 8th grade, right? But what you do in 8th grade science, one of the big things is a scientific method. And you may repeat that, you know, at other times. Do you remember, any of you remember the scientific method? Some of you might have done it more recently. Not seeing y'all jump in, but can you remember the scientific method? Not hearing you all say yes. Yeah, hypothesis, conclusion, test. Not sure what test is, but it's usually hypothesis, data gathering, or experiment, and then conclusion. Yeah, so observation, research, hypothesis, experiment, analysis, conclusion. Okay, so what I'm going to do is I'm going to talk about hypothesis testing. I'm going to be doing this in a very strict order. There aren't a lot of choices. And now that we're not in 8th grade, it's a little more sophisticated, as you should expect. But that's what we're doing. And it turns out, when you think about science, most of you probably think about biology and chemistry and physics. But it's actually social science also. So psychology uses a scientific method. Sociology does, communications does. Most fields use it. And in fact, the only field where if you have to like write a master's thesis or dissertation, there's really only one field I know of that doesn't use it. And it's totally strange until you think about it for a while. And that is math. Because for math, you have to prove it. And for every other subject, you don't prove it, you get evidence. That's the difference. So just to let you know, one word that you should never use in your paper or any of your writing is proof in this class. So I will take off points if you say you proved this, because you didn't prove anything. All you did is found evidence for it. Okay, so what I want to do is I want to do it by example, but we're going to go slowly. I'll go through every step of the process. So let me share my desktop. I have learned that I need to go to Zoom so that you can see everything. And I'm just going to do kind of a stock example, but that works. Let me go find it. Or not Zoom, sorry, Paint is what I meant. Okay, so there's the Paint. And let me make sure I'm looking at the chat. There we go. All right, so here's the question. Oh, there's a typo there, sorry about that. Should say, in the US, 1.5% of children are autistic. A researcher wants to see if this percent is higher for children who are vaccinated. Okay, this is kind of a big deal in terms of the news lately in the last few months. Okay, suppose that of 5,000 vaccinated children tested, 77 of them are autistic. Use a 5% level of significance. All right, so the way it works is the first step is to write down a hypothesis. And I want to let you know that when you're doing your project, that's going to be your first step also. And that, because it's your first step, I guess after finding a partner, but once you found your partner, you are going to come up with a hypothesis. And my strong recommendation is when you come up with a hypothesis, post it in the Project 2 discussion board. I'll take a look at it and let you know if this hypothesis can work. So it's just, so each week I'm going to talk a little about the project as I go. Last week we talked about confidence intervals. This week is hypothesis testing. Those are the two main things in the project. Next week are the specifics of the project. So the first thing we want to do is what's called state the null hypothesis and the alternative hypothesis. Okay, so when you're looking at the null hypothesis is kind of the status quo. Okay, there's no difference, everything's the same, whereas the alternative hypothesis is your idea that you want to see if it's true, is the idea. So the letter we use for hypothesis, hopefully you could probably guess this, is H for hypothesis, and we use a capital. So let me write down in the hypothesis. We're going to write H and then not is what we say because the British got to it first, and that's how you say 0 in British. So it's H sub 0 or H naught. And what that is again, the statement that if there's nothing different, then that's H naught. So in this case, notice a survey question. What are we going to ask this child or the parent of the child? Okay, what is a survey question going to be here? And again, the survey question is about the individual that you're asking. It's not about what you're trying to show is true or not. What are you going to ask the parent of the child? What's the survey question? See if you can type in the survey question in the chat box. Or say it, that's fine too. You should all be typing at once. Have they been vaccinated? It's a good thought, but not quite actually. It turns out that we're going to be looking at vaccinated children for the population. What's the survey question? What are we going to ask this parent? Yeah, are you autistic? Okay, or is your child autistic? Does that make sense? So because of that, the survey question's answer is either yes or no. Is that clear? So when you have a yes or no question, what letter do we use for the statistic? You should all know this because it happened in confidence intervals. And it's happened before too. For the yes or no question, what letter is it? It's P. P for proportion. The proportion of those who are autistic. So P, and if the status quo is true, then you would say that among the vaccinated children, it ought to be 1.5%, and as a decimal, that's 0.015. Any questions on this so far? Okay, next, we need to find what's called the alternative hypothesis. The alternative hypothesis is what the researcher is trying to show is true. Okay, what we're trying to find evidence for. Okay, and the first thing is there are two different ways of writing it. I'm going to use H1. Sometimes you'll see HA. In your calculator, it says H1. That's why I'm putting it as H1. But sometimes you'll see research, you'll say HA for alternative. And that's just, there's no particular consensus on what to use. So either way, if you use H1, if you use HA, that's fine. And the first thing is, it's the same letter, P. It's about the proportion. So what is the researcher trying to show? And there's a key word in the question. Yeah, greater than. And the key word is higher. Do you see that? They want to see if the percent is higher for children who are vaccinated. That's going to be greater than 0.015. Any questions on this so far? Okay, so the next thing is we want to discuss the ramifications of a type 1 and type 2 error. So first we have to understand what they mean. So let's start out with type 1 error. And 18 is probably better. So type 1 error means that we rejected H0 when H0 is true. Because that's an error. You said, H0 is not true, and you were wrong. Okay, and again, in any study that could happen. Rejecting H0 is the same thing as accepting H1. And a type 2 error, first thing is you never accept H0. You only what's called fail to reject. When H0 is false. So if you ever accept the null hypothesis, I will take off points. Any questions on that? Okay, and by the way, this is on the midterm. This week's stuff is on the midterm because the midterm's not officially until next week, even if a couple of you are taking it way early. But this is on the midterm, so be ready. Okay, so we fail to reject H0 when H0 is false. So failing to reject, saying we didn't have evidence to say that the autistic percentages for vaccinated children is higher than 1.5%, but it actually was. All right, so now I want to look at the ramifications. A lot of people have trouble with this word. What does the word ramification mean? See if you can type it in or talk about it. Yeah, the consequences, the bad stuff that happens because of it. Okay, why this is going to be horrible for you, who it's going to damage. Does that make sense? Who it's going to hurt. Those are ramifications. Okay, if you do not discuss the ramifications when I ask you to discuss it, if all you do is define the type 1 error, I will take off points. I want to hear about who gets hurt and why. Okay, sometimes I'll say what damage is done. It's the same thing as discuss the ramifications. Okay, so let's start out with a type 1 error. Okay, again, a type 1 error is reject H naught when H naught is true. So if we reject H naught, we have decided that H naught is false. And if you decide H naught is false, that means you're going to say we have evidence to say H1 is true. So if you have evidence to say H1 is true, that means we're saying that vaccinated children have a higher autistic rate. What's going to happen? Okay, but on the other hand, they don't. So what damage is done if that's what the national research shows? The national research shows that vaccinated children have a higher autism rate, but actually they don't. What damage is done? See if you can tell me what damage might be done because of that research that was just done. Yeah, what's going to happen is people are going to question vaccinations, and they're not going to vaccinate their children. Have you heard of that happening, by the way? Okay, yeah. But that's not the damage. We haven't gotten to the damage yet. Okay? The thing is, it doesn't have anything to do with autism and what damage is going to be done. Okay? That doctor lost the license, exactly true. Okay? What damage is going to be done other than the doctor losing the license? There's worse damage than that, actually, because it's been happening. Children won't be treated, keep going. What damage will be done? Much worse than not being treated, by the way. Yeah, not more children have autism. It's the opposite. Yeah, children will die, okay? Children will die and have horrible diseases that they wouldn't have had otherwise. Does that make sense? So let me type this out because it's really important. So let's go type 1. So a type 1 error means that the researchers published that vaccinated children are more likely to be autistic. How about have a higher rate of autism? Okay. But they don't. But the researchers were just wrong. So what will end up happening, the result is more children will die of diseases that could have been prevented by vaccinations. And it has nothing to do with autism. Okay, any questions on that? Okay, by the way, is that a pretty bad ramification or is it no big deal? Yeah, if you don't say bad, there's something really wrong with you. If you're okay with a lot of children dying, that's not okay. All right, let's go to the type 2 error now. Change the color a bit. Type 2. Okay, so a type 2 error means we failed to reject when we failed to reject H naught when H naught is false. Okay, so if we fail to reject H naught, what does that mean in terms of publications? Any thoughts? But they fail to reject, what does it mean in terms of publications? That research you're publishing. What will happen? Okay, they're not accepting actually. So when you fail to reject, what it means is you don't have evidence. And if you don't have evidence, then you don't get published in a journal. Does that make sense? So you're not going to say that autism is not caused by vaccination. You're just going to not publish. So the result is no warnings about autism take place. But vaccinations do cause autism because we said H0 is false. That means H1 is true. And then there's a higher prevalence of autism for vaccinated children. All right, what damage will be done now? So what damage will be done now? What are the ramifications? There'll be less vaccination? Not quite, actually. That's what the last one was. That's what type 1 was. Type 1 is we didn't vaccinate. Yeah, there'll be more autism. Okay, so more children will become autistic. When it could have been prevented. Okay, not necessarily by not vaccinating, but by maybe changing the vaccination to make it safer. Does that make sense? Because vaccinations, and I hope you all agree, are important. Okay, if you go back, if you look at President Roosevelt, for example, there's a reason why we vaccinate everyone now. If you know about Roosevelt, he had polio, I guess it was, and horribly crippling in a wheelchair because of it. It's a good thing we have vaccinations because we don't have that anymore. Okay, any questions on a type 1 and type 2 error? Which is worse in this case? Type 1 or type 2 for this case? What do you think? Yeah, I believe 1. I'd rather have maybe a little more autism than a whole lot of children dying. Maybe you agree? Okay, so I want to let you know something. The next thing we're going to do is we're going to have to see what our level of significance is. So maybe I'll do it. I don't want to do black. Let's do another color. So let's look at the level of significance. There we go. So the first thing is the letter we use for level of significance is, let's see if any of you know, the first letter of the Greek alphabet. Anyone know what that is? Yeah, alpha. So the level of significance is called alpha. And what we have to decide is what should we let it be. And just let you know that the standard is 5% or 0.05. So what you want to do is you want to say, do you want to move from the standard? If type 1 is a lot worse than type 2, then you want to go down from 0.05. If type 2 is a lot worse than type 1, you want to go up from 0.05. So what should we do this time in this particular example? What do y'all think? Yeah, we want to go down. We want to go down because a type 2 error, type 1 error is really horrible. So we want to make sure there's a very small chance of a type 1 error, and the level of significance is a chance of a type 1 error. So what we're going to do is maybe we're going to set alpha to be equal to 0.01. Make it smaller, 1%. So we got to be damn sure, right, with very small chance of being wrong is the idea. Any questions on that? Okay, next is sample size. Is the sample size large enough? So the way you find that out is we take p, which is 0.015, and we multiply it by n, which is 5,000. So 0.015 times 5,000 is equal to, and that is how much? $75, hopefully. Any questions on that? And 0.985, which is, by the way, the chance of not having autism, times 5,000 is much bigger. That's equal to 4,925, if I did that in my head right. What's important about these numbers? Thank you, but what's important about 75 and 4925? Yeah, they're both greater than 5. And Brenda, I see you asked, will we always be 0.01? So in this class, again, this is elementary statistics. I really want you to know the kind of the difference between the standard, below the standard, and above the standard. So for us, if you just use 0.01, 0.05, and 0.1 as the three possibilities, that'll be good for this class. There are times you want to go even lower than that, but we're going to stick with those three because those three are the main three that people use. So 1%, 5%, and 10%. Okay, notice these are both bigger than 5. So both greater than 5. So the central limit theorem tells us we have a normal distribution for the sampling distribution. Approximately normal. So that means, yes, it is okay to continue. If you don't have bigger than 5 in both of those numbers, don't even think about running a hypothesis test. Okay, you get a bigger sample size. Okay, you don't know, it's really sad. People come to me, past students 2 years later, and they come to my office for help. And by the way, I'm always happy to help you out. Once a student, you're always a student. I'll always help you in statistics. And then, unfortunately, sometimes they leave crying because I tell them that NP is smaller than 5 or 5 or less, and your sample size is too small, and you can't publish. Okay, you have to have a big enough sample size to be able to have valid data. Okay, so it's sad, and I say you need a bigger sample size, and they say, well, I don't have time. I have to, defend my thesis soon, and it's like, well, you're not gonna be able to publish this. They're never happy. I don't like being the bad guy. So hopefully you guys will remember that you need big sample sizes. If it is quantitative, this was a yes/no question, but had it been a quantitative question, what's the key number? It's not 5 anymore. What's the key number? If you remember. Don't see y'all typing it in or saying it. Okay, if it's a quantitative question instead of a yes/no question, what do you have to be bigger than? .25, no. Maybe I should just tell you 30. Remember that number? Ah, there we go, Jocelyn. Got it. So 30. You have to be bigger than 30 for a quantitative question. For the yes/no, and P and MPQ have to be bigger than 5. Any questions so far? Okay, so the next thing I need to do is I need to actually find what's called the p-value. I want to draw some pictures first. So I hope it's okay. I got to erase this because I only have so much room. So I'm going to erase a bunch of stuff. Type 1 error we answered already. Type 2 error we answered already. Okay. What I'm going to do now that we know it's a big enough sample size, that means I know that the sampling distribution is approximately normal, and I can draw the picture. The central limit theorem tells us that the mean of the sampling distribution is a proportion. And the proportion, if you remember, was 0.015. Get it one more time. So that's where that goes. What we want to find out is it greater than 0.015? And see this alpha is 0.01? What I'm going to do is over here, I'm going to shade this in. It's greater than, so we're on the right-hand side. And I'm going to say this is 0.01. Any questions on the picture? That's called the rejection region. Had H1 been a less than instead of a greater than, it would be on the opposite side. Had it been a not equal to, it's on both sides, and you'd have to divide alpha by 2 because it's both sides. But in this case, it's a greater than. Any questions so far? Okay, so if we're in this rejection region, then we're going to reject the null hypothesis. If we're outside of it, called the fail to reject region, we're going to fail to reject the null hypothesis. So what we need to do is we need to find out, based on the central limit theorem, the probability that you would have such a rare event as 77 being autistic out of the 5,000. Any questions so far? Okay, so now we go to our calculator, and we're going to find the p-value with our calculator. And the p-value is that probability that if we conducted a study of 5,000 vaccinated children, such that really only 1.5% of all vaccinated children are autistic, then we would end up with a result at least as big as 77 that were autistic. So I'm going to go to my calculator, so I got to reshare my desktop. To clear what we had last week. Okay, so I recommend you follow along. So in this case, we're going to go stat, and we don't have data to put in. This time we just have proportions, and we'll get our tests. And now we're doing a hypothesis test. We're not finding a confidence interval. So we're going to be looking at a one-prop z-test. So let me talk about what that means. One, because there was just one survey taken, and that is is your child vaccinated? Does your child have autism? Prop, because it's a yes or no question, proportion. Z, because we had a large enough sample size. And test, because we're doing a hypothesis test. Any questions on that? Okay, then we go enter. And then we have P naught. P naught is 0.015. X was 77. That was a number of children with autism. We had N was 5,000. Our alternative hypothesis was a greater than, remember? Don't worry about color. We're not doing that anyway. And then calculate. Any questions before I hit calculate and the screen goes away? Everyone good with it? Okay. So there we have it. So first thing, a couple things. Z equals 0.23, 0.2327 actually, to 4 decimal places. That's called the test statistic. So if I ask you for the test statistic, that's, in this case, it's Z. Sometimes, in other cases, it could be T, and we'll have some others later on in this class. But right now, it's either going to be T or Z. Our p-value, that says P, is 0.4 about. Any questions on that? These were our data that we got. So 0.4, I'm going to leave the calculator and go back to the paint. So first thing, P was 0.4. Okay. Let's write that in. I want to go text. There we go. So p-value is equal to 0.4. And 0.4 is definitely bigger than 0.01. Because that's what you're always doing. You're saying, which side are you on? Are you on the shaded region side, or are you not on the shaded region side? And if you're on the shaded region side, then the area to the right will be very small. If you're on the not shaded region side, the area will be bigger. And that's everything. So now comes the conclusion. Okay, so let's state our conclusion. And you need to have this wording down. There is statistically significant evidence. Okay, those are important words. It's not the same thing as I proved it. It's just, actually, sorry, statistically insignificant because we failed to reject. Evidence. To make a conclusion that the population proportion of vaccinated children who are autistic is greater than 1.5%. I just want to let you know, please repeat what is the Z standing for. Z is a normal curve number. It's a standard normal curve number. So you're used to, if Z is like bigger than 2, then that's going to give you a very small probability, right? Or less than -2, for example. Okay, RZ was, I think, was it 0.23 or something? Not that far from 0. And if it's not that far from 0, you're going to have a p-value that's large. Does that make sense for us? Okay. Any questions about the conclusion? By the way, does this conclusion sound about right in terms of reality? If you did a study, do you think you'd find out that vaccination and autism are related? Okay, you wouldn't find that out, so we say there's insignificant evidence. So would it be significant if we got right on 1.5%? First thing, it's not 1.5% that matters. It's the 1%. It's the alpha, the level of significance that matters. Does that make sense, Bailey? So it's the 0.01 that we're comparing with, not the 0.015. Second is you can't get right on 0.01. If you go enough decimal places, you'll be on one side or the other. And trust me, the probability is 0 to be exactly 0.01. It won't happen. So you don't have to worry about it. But 1.5% is not what you're looking at. It's the 1% of the 0.01 for comparing. Any questions on this so far? Okay, so our p-value is 0.4. Just a note, I think it's worth doing. I want to draw the picture. So 0.4 is that area right there. Any questions on that? So that area is about 0.4. 0.5 is right in the middle, right? 0.4 is a little less than that. So that's the first thing. The second is we want to think about that 0.4. If you had a 0.4, you have a 40% chance of something happening, and then it happened, would you be like totally surprised? Or would you be like, oh yeah, it happened? What do you think? Yeah, no big surprise, right? Okay, our definition of being a big surprise in this example is what? Yeah, actually anything less than 1% is a big surprise. Like if there was only a 0.5% chance that our results could have happened, given the fact that p was 0.015, then you would say, boy, that's a huge surprise. So if it's such a surprise, you're going to say, I'm not going to accept that p is 0.015. I have evidence to say p is greater than 0.05. And that's what this is all about. Any questions on that? So the p-value is all about. Okay, now it's time to interpret the p-value in words. So what we're going to say is that the p-value is a probability, and the first thing we did is I drew that normal curve and I popped in 0.015. You all saw that, right? So we're going to say if the proportion of all vaccinated children who are autistic is 1.5% or 0.015. And if we conducted another study of 5,000 vaccinated children, then there would be a 40% chance, that's what the 0.4 is, that this study, or the new study, would produce a sample proportion of at least. Okay, and you may not have noticed, but in the calculator, it gave us what p hat was, which, by the way, is just 77 over 0.4. And that was 1.54%. Any questions on interpreting the p-value? All right, now I need to erase. There's a lot of writing in this chapter, by the way. Have you noticed? So I'm going to have to do some erasing. So let me go to select. There we go. I'm going to erase the level of significance because I need the space. Okay, so now I need to interpret the level of significance. And the level of significance was 0.01. I have it up here. The p is equal to 0.4, which is greater than 0.01. So time for that. I'll do that in brown. Okay, the first thing with the level of significance, I think I need to write a little smaller or I'm going to run out of room really fast. Is that we start the same way, exactly the same way. If the proportion of all vaccinated children who are autistic is 0.015. No, this is just restating H naught. And if we conducted another study of 5,000 vaccinated children then there would be a, now it's a 1% chance because we decided our alpha was 1%. Chance that the new study would end up falsely concluding that more than 1.5% of all vaccinated children are autistic. But just a note, the 0.01 is the probability of a type 1 error. Because that's what type 1 error is that if H naught was true and needed another study, then that would be the percent chance of finding out or ending up concluding that H1 was true. Any questions about this example at all? There's a lot going on here. I want to mention something. This is great for the midterm. That's for the level of significance. I would have put it in, but I ran out of room, sorry. So let me note something. I'll do it in yellow. There's your 1%. Now the 1% is there. Do you see? So we are looking at the 1%. But it's all in there, not just the 1%. But the 1% is the probability of something happening. Do you see? Of the type 1 error happening. Any questions at all about this example? Okay, I want to do one more example before we talk about the midterm. Again, my warning was I'll probably go a little over today, because unless you don't want me to go over the midterm ideas, but I think you all do. So This is a very important week. So let me go ahead and I'm going to erase everything. Okay, question? No? Okay. All right, so let me erase speak now or forever is erased. Gone. Okay. So now let me do another example. I gotta move things over. And this is motivated by what I was doing on Saturday. And you might know what I was doing on Saturday, given the fact that I told you I was doing what I was doing on Saturday. Anyone know? The hint is I mentioned it would be a nice way of looking at your project or getting your project started. I don't know if anyone saw. Did you read my announcement? Yeah, collecting data for the watershed. Snapshot day, it's called. So that's what we did. So I actually tested some of this turbidity. Okay, so, and if you don't know what turbidity is, that's okay. You don't have to be a scientist, but you just have to be able to handle numbers. Okay, so let me read this question. Okay. You're in Afghanistan, okay. Oh, that's right, military. Otherwise, that's not a place people go to by choice. All right, so the average morning turbidity in Lake Tahoe is 0.4 NTUs. A study of summer afternoon lake turbidity in Lake Tahoe was measured at randomly selected days and locations to see if the turbidity is higher in the summer afternoons. And the results are shown below. So we have a bunch of numbers here. So the first question is state the null alternative hypothesis. All right, so here, let's start there. We need to state the null alternative hypotheses. Actually, let's do it with a pen. I mean a brush. All right, so the null hypothesis, remember we use the letter H naught. And I want to mention, because some people make mistakes, what I just wrote is a colon, not an equal sign. Don't ever write H naught equals, it's H naught colon. Okay, now, the next question, this is really important. What is the survey question? For this study, what was the survey question? Okay, so Brenda, that's not the survey question. It's not is the turbidity higher in the summer. That's the question of the study, which is not the same thing as the survey question. So you had a scientist just collect it. You have a scientist just collect one data value. And what are you going to ask that scientist? Yeah, what is the turbidity of the water? So that means that this is quantitative. Very important. This is not a yes-no question. It's a quantitative question. What was the turbidity? What was the measurement of the turbidity? And if you look at the data, it's a bunch of numbers, not a bunch of yeses and nos. So when you have a quantitative question, the letter we use is not P, but mu. And I will take off points if you get that letter wrong. If you write P instead of mu, that's not good. Okay? And then with H naught, we always have an equal sign. And then it'll be 0.4. Any questions on that? Okay, then we're going to have H1, the alternative hypothesis. I'll write HA just for fun because I wrote H1 last time, and it could be either. And then you're going to have a mu. Okay, and what is the inequality here? It's a greater than. Not sure where 0.6 comes from, but greater than is what we want, 0.4. You could have greater than, less than, or not equal to. Those are the choices. There's another greater than. Okay, so the next thing we need to do is we probably need to decide what the p-value is on this one. I'm sorry, what the level of significance is on this one. And this is one of those where you look at the type 1 error, you look at the type 2 error, and I don't have that much time, so I'm going to say that they're probably pretty similar in terms of ramifications, in terms of the trouble that they cause is about the same bad trouble. Different things, but one is that you don't know that afternoon is worse, and maybe you're not going to be able to have special regulations in our lake. And that'll be bad for turbidity. Turbidity is a bad thing, by the way, for our lake. Okay, that would be a type 2 error. Type 1 error is that we thought that turbidity was higher in the afternoon, and we got regulations. So one is we have all these regulations and it doesn't help anything. And the other is, and maybe morning is worse, and that's a problem because we regulate in the afternoon and it gets worse. The other is we didn't know afternoon was worse. So we didn't do special regulations in the afternoon, but afternoon was worse and the lake gets worse. So it's about the same in terms of badness. So because of that, I'm going to let my level of significance, alpha equals 0.05. %5 is what you do when it's about the same. Any questions on that? Okay, now we're going to go to our calculator. Okay, so I'm going to pop my calculator up. Let's do that. And let's clear what I had. This time we're given data. So I need to go to stat, I need to put that data in. I need to go up to L1 and I need to clear it. We've seen this before, so I'm going quickly on that. Then I type in my numbers. 0.55, and then 0.42, and then 0.38, and then 0.91, and 0.74, and then we're going to have 0.88, and then 0.27, and then 0.56, 0.71, and then 0.55. Then we have 0.41, 0.47, 0.33, 0.68, 0.49, 0.55, 0.46, and 0.60 or 0.6. Okay, the next thing we do is we hit the stat button. We've seen this before when we typed in data and we did confidence intervals. We put the data in and then did confidence intervals. Same idea with hypothesis testing. I can go to tests. And what test am I going to use now? Any guess? Any guess on what test to use in the calculator? Any thoughts? Yeah, this is going to be a t-test. Okay, T because we have quantitative data, test because of the hypothesis test, and it's just one sample. Next week we'll do 2 samples, by the way. Then go down to t-test and hit enter. We have data. If it's on stats, move it over to data and hit enter. And then go down. Mu naught, that is our null hypothesis. Our null hypothesis was that mu is equal to 0.4. So it's 0.4. The list is L1, because that's where I put it. Freq is 1. We have a greater than, so I'm going to leave it at greater than. And then I go to calculate. All right. Let me ask you something. What is the p-value? What is the p-value? See if you can type in the chat box. Okay. 3.6 is the test statistic. Okay. Yeah, the p-value is 0.000918, etc. Notice that E negative 4. That's scientific notation. It means move the decimal place over 4. Okay, so it's a very small p-value. So let me reshare my desktop. So our p-value was about equal to 0.0009, something like that. It was 9 and more stuff, but that's okay. It's very small. Any questions on the p-value? What's the important thing about this p-value? What's important? Like, how are we going to use it? What are we supposed to look at it and say? Yeah, it's less than, oops, let's go to text. It's less than 0.05. Is that clear? Okay, and not only that, it's a whole lot less than 0.05. Typically, if it's less than 0.01, that's really small. So now we can do our conclusion. Alpha is 0.05, not 0.5. And we chose that because we decided that a type 1 and type 2 error were pretty similar in this case. So we chose our alpha to be 0.05. You see it's up on the board already. We talked about that a little while ago. So type 1 and type 2 are pretty similar. Okay, use 0.05. If it's in the news, you always use 0.05. That's standard. So what we can say is there is strong. Strong because it's very much less than 0.05, statistically significant evidence. That the population mean, NTU, in the summer afternoons in Lake Tahoe is greater than 0.4. Any questions on the conclusion? Okay. I didn't ask for, in this example, I'm not asking for interpreting the p-value, interpreting the level of significance. You should learn how to do that in every case, but I will always ask for the conclusion, and I will sometimes ask for all the other stuff. So that's just a note. Okay, what about, do we need to assume the distribution of turbidity in Lake Tahoe is normally distributed in order to trust these calculations? What do you think? What do you think? So do we need to assume part D now? Oh, actually, I haven't gotten to part C yet. Maybe I should do part C. All right. Well, let's do D first since you're talking about it. All right, let me talk about it. We have the central limit theorem. What is the sample size? Yeah, sample size is 18. What's important about the number 18? What's important about the number 18? It's all about that number. Not greater than 5. Greater than 5 is with yes/no questions. Yeah, it's less than 31, actually. Is less than 31. Or you can say less than or equal to 30, either way. It's less than or equal, it's less than 31. So the central limit theorem does not guarantee that the sampling distribution is normal. So we must assume the population distribution is normal. Remember, there are two ways of getting normality. One is the population was normal, and the other is if you had a sample size greater than 30 for the quantitative study. Any questions on that? Let me just quickly interpret the level of significance. Since I think I have just enough room to do it. So you always start out with stating the null hypothesis. So if the population mean, that's what mu stands for, turbidity is 0.4 in the afternoon, and if we sampled another 18, what did we sample? 18 samples. Then there would be and again, our level of significance was 5%. So 5% chance that we would end up falsely concluding that the population mean turbidity is greater than 0.4. Any questions at all on the interpretation of the level of significance? Any questions on that? Okay, I want to let you know I do not have time to do every kind of example. Definitely watch the long video, look at lots of examples. I only have so much time. I want to go over the midterm too, and I don't want to take you all night. But are there any questions at all on, I did the yes/no question example, and I also did a question about population means or a quantitative question. We got to see a fail to reject, and we got to see reject. So we got to see those types. We only saw a right tail test, which means a greater than for HA, but there could be a less than, and that would be a smaller than or less than. There could also be a different from, and that's a not equal to. So a few things to note. Well, the midterm have both types of questions. We'll look at that in a minute. Okay, I'm going to talk to you about a little about the midterm. I'm not going to tell you every problem, but I'm going to give you the idea of each problem. First, any questions at all on this? Okay, what I want to do now, before I talk about the midterm, any guess? The secret word. I figure you'll all going to want to stay for the midterm review, so I can get away with the secret word now. So the secret word of the day is significant. Because when you're doing your conclusion, you either say it is statistically significant or it is statistically insignificant. So the word significant is really important. Okay. So the project doesn't really have questions. You're going to do one survey, and you don't know, and that's going to be for the mean. We'll talk about that next week. It's going to be for the difference between population means. So we're not ready for the details yet because we haven't had them yet. But the midterm we're ready to talk about. So you guys ready to talk about the midterm? Unless you have questions. All right, so let's go to talk about the midterm. And let me go find it. That's that one. Okay, so I want to jump into Canvas, and I want to show you what I recommend doing strongly. Week 8 is your midterm. That's next week. Okay, first thing, by the way, last time I saw there were 13 of you who did the midterm information. That is due on Wednesday. Don't wait to, or I just take 5% off on your grade, and that sucks. So don't even think about that. You need to do the midterm information. Let me know. I'm going to be sending out tests by Wednesday. Actually, I think one of them I'm going to probably do tomorrow, or 2 of them, because you're taking it on Wednesday. But I'm going to be doing that. So make sure you do the midterm information. I think there again, 13 out of over 30 of you have done that. So there's a lot more to do it. Okay. But more importantly, in week 8, I think the most useful is this one right here. It's a 201 online S19, Spring 19 shell. And what I did, I have already written your midterm. I wrote it a while back, 3 weeks ago, 4 weeks ago, something like that. So what I did is I erased parts of it that I didn't want you to see. But the parts I didn't erase, I posted. So let me click on it. Okay, so this is the midterm. There's only one, there's a few differences. One is that you're going to have all the information instead of just some of it. So let me read some of this. Please work out all of the given problems. Credit will be based on the work that is shown that contributes towards the final answer. So if you don't show your steps, I don't give you points, okay? If all you have is the answer and there are 4 steps, then you get 25% because you've got one of the steps right, but the other 3 you didn't do. So you need to show your steps, okay? If you're using the calculator to solve a problem, be sure to write down what you're putting into your calculator. So if you're going to do, for example, a one prop z-test, then I want to see the word one prop z-test. So I want to see what you're using in your calculator. Does that make sense? Only takes a second or 2 to write that down. So don't forget to write that down. And I'll give you credit if that's the right thing to do, even if you did it wrong. You'll get some points. Not 100%, but you'll get some points. Okay, also show all student normal and student t diagrams. That's the normal curve. So if you need to write a normal curve, you need to write a normal curve and you should show it. Okay, then what I've done is I have written down the questions. These are the questions. There is one difference between the practice test, between the shell, sorry, and the real midterm, is in the shell there's not a lot of space to do anything. Okay, I wanted you'll be reading through this. I didn't think you needed a whole lot of space when you're reading this, but there's a lot more space. It's many pages when you do the real midterm. All right, so the first question. Let's take a look. For each part, be sure to write down the sampling distribution for each. Put in your normal curve, answer the question, determine whether an anomaly assumption was needed. So how many things do you have to do for each part? Should be obvious. It's not a trick question. 4. Okay, so when I say put in your normal curve diagram, write down the sampling distribution. Do you remember what sampling distributions look like, what the notation looks like? I think I'll write it, even though it gets weird when I start scrolling. Remember what it looks like? Maybe I'll put it in the chat box, but I'll say it as I type. It looks like something like possibly X, might be X bar, could be sigma X, and then there was a tilde, and then there was an N, a capital N for normal, and then a parenthesis, and then the mean, which was whatever number that is, maybe 25, and then the standard deviation, which might be, I don't know, 5.4 or something, and then end the parenthesis. That's what it means to say write down the sampling distribution. So you've seen this before. I want you, and there's an A and a B, so there's 2 of these, so there's 8 total things to do. So I want you to put I promise when I say on this part 1 that you're going to have a tilde. Can you type in I promise? Okay, why am I asking you to say I promise? Any guesses? Okay, it's because I've been doing this, giving the same kind of problem for years and years and years, and usually about half the students don't even do the tilde thing. They just leave it blank, or they just write down the mean and the standard deviation, that's it. But I want to see the notation. Okay, so I did it in the chat box. Oh, you know what? Oh, it went private. Only one person saw it. Sorry about that. Let's do it one more time. That's not what I want. That one. Everyone. There we go. One more time. This is an example. And it's X tilde N, and then it's the mean, which might be some number, comma, and then it's the standard deviation, which is going to be some number. Now, if you're using central limit theorem and it would say X bar, then you're going to divide that standard deviation by the square root of the sample size. And that'll change your standard deviation. Whereas if it's the sigma X, if it's a summation or total, then your mean is going to be multiplied by the sample size, and the standard deviation is going to be multiplied by the square root of the sample size. So remember, there were central limit theorem formulas. So it's pretty deep. Okay, most people do number 2, which is to draw a normal curve. But hopefully you know how to do that, and I want to see shading. Okay, and if you're going backwards, then the probability should be marked above the graph, and the X or the question mark or the whatever it is should be marked below. Okay, the third, that's the part everyone at least attempts to do, and that's using your calculator and giving me the number. The fourth, for some reason, a large number of people don't do the fourth one. Okay, so if you want to find out if the normality assumption was needed, then you're looking at the sample size. If it's quantitative and the sample size is greater than 30, it's not needed. If the sample size is less than 30, or if it's just a single individual, it is needed. If it's a yes-no question, NP and NQ have to be bigger than 5, and then it's not needed. Any questions on problem 1? All right, I recommend you practice. Can you say that again? Okay, so again, if the sample size is bigger than 30 and you have quantitative data, then you don't need the assumption of normality. If the sample size is 30 or less and you have quantitative data, or if you just are looking at an individual, then you do need the assumption of normality. If it's a yes-no question, NP and NQ have to be bigger than 5 to not need to be able to use normality. Okay, and this all happened when we did central and midterm. So this is a chapter 6 and chapter 5 possibly too. So it's a 5 and 6 chapter. 5 and 6, no, sorry, 6 and 7. Got the wrong numbers. Chapter 6 and 7. Okay, any questions on number 1? Okay. Okay, and by the way, in number 1, I'm not giving it to you, but there's going to be a paragraph in here. Otherwise, you can't do anything, right? So I'll give you information. And then for A and B, there'll be questions. Okay, problem number 2. Okay, just a note, by the way, if you don't practice, you're not going to do well at all. How many should you practice? $100, I think that's torturous, but if you want to do 100, you can. I think more likely, my recommendation is you keep practicing until it just becomes natural, right? You're not looking things up and trying to like remember how to do it. You just write it out, okay? And when you get to the point where you can just do it, then you're ready. And that's my recommendation for all of these problems. Okay, and you're always welcome to go back and do, for example, the chapter 6 and the chapter 7 exercises. When you do that, try not to read the answers, only read the question and then do all this stuff. That's my recommendation. Okay, problem 2. There'll be a paragraph, and then I have questions. Discuss the implications. You could redo homework problems. You can go on the discussion posts and look at those. Okay, so there's lots of ways of practice, lots of problems. You can go to the book, and there's lots of problems in the book. So those are all practice questions. So yeah, there's lots of resources. So the book has lots of questions too. And again, problem 1 is chapters 6 and 7 in the book. So do a lot of those. Okay, problem 2. What chapter do you think problem 2 is? Yeah, that's chapter 9. We just did it. I shouldn't have to spend a lot of time reminding you how to do this one because we just did it. So part A, discuss the implications of a type 1 error. There'll be a paragraph above it. Part B is discuss the implications of a type 2 error. Part C is test the hypothesis using alpha as 0.05. Be sure to state the null and alternative hypotheses, the p-value, the test you're using in your calculator. Then state the conclusion using a complete sentence in the context of the study. Practice. Okay, practice. Do the homework. Please do the homework in chapter 9 and make sure you do lots of writing on it. Also, the discussion posts. I'm making you do one of these in the discussion posts. Look at each other's, look at my example. Look at the examples in the webinar too. Those are more examples. Okay. This one you don't have to do a visual, but if it helps, you can do it. And you might get some partial credit if you're not sure about things. Okay. A lot of students don't like this problem, but I'm giving it to you anyway. Very simple instructions. Please circle the following true or false. And there's going to be an A, B, C, D, E, F, G, and H. Okay, they're true, false questions. Where have you seen true, false questions before? Yeah, homework. Yeah, my calculus class too, but most of you haven't seen that. Homework. So Betsy knows that's my style to do true, false questions. Okay, but I want to show you another place where you can do true, false questions. If you type in my name in Google, I'm usually towards the beginning. And if you go to, it is, where is it? There's a lot of stuff here. All right, I might need to do more then. There it is. So if we go to statistics, comprehensive review, and I've made an app. You can do it on a phone. I use JavaScript, so it should work on any device. And these are true, false questions. All right, which one should we choose? Which one should I check? Should I check them all? Definitely hypothesis testing. Yeah, the first four. So I recommend doing the first four. The last three, by the way, that'll happen for the final exam. You're going to want to do all of them for the final exam. But for now, we can just go like that and hit submit, and then you'll get lots of these. There are hundreds that I've made. And don't just click and just don't read the rest. So let's do one of these. A class has 35 students. Let A be the event that a randomly selected student is male, B the event that the randomly selected student is a math major. If A and B are mutually exclusive events, then the probability of A and B equals 0. Let me ask, true or false? Okay, so let's click true. And it was true, and that's because for any mutually exclusive events, probability of A and B is always equal to 0. Okay, again, do a lot of these until you get good at them. Any questions on this? So let me show you how to get to that page. Let me do this. From the home screen. If you go to course information, I think it's in there, you go to review applets. And then you link, and there it is. And then it's the one that says practice true false. So it's on the Canvas page. Okay, let's continue. So that's how you practice that one. All right, problem 4. I'm vague on purpose. It's a question from chapter 4, 5, and does have some chapter 3 stuff. So I'm not telling you much, but you need to be able to know the old chapters. Problem 5, question from chapter 2. Okay, problem 6. Determine the appropriate 95% confidence interval. Write down a sentence that explains your findings. Use a sentence or two to explain what it means in the context of the study to be 95% confident. Was it necessary to make any assumptions about the underlying distribution of the population? Explain. When did this happen? Yeah, this was last week's. Okay, chapter 8. So get good at it. Okay, problem 7. I didn't want to just rewrite the whole thing, but another confidence interval question. Confidence intervals are very important, so I have more than one of them. So notice that the new stuff is weighted more heavily. All right, problem 8 is this week's stuff, chapter 9. Again, the confidence intervals and hypothesis tests, they're really the most important part of the class. So it's a heavy part of the midterm. So write down the null and alternative hypothesis, find the test statistic and p-value. Use a complete statement to state the results in the context of the study. P-value represents a probability. Write a few sentences to interpret this probability in the context of the study, and same idea for the level of significance. Okay, so practice, practice, practice. Problem 9 is a question from chapter 1, 2, or 3. Okay, and 3 actually. So it has different parts, and you have to use all kinds of stuff. Okay, problem 10 is extra credit. Okay, and here I actually wrote verbatim, and all you have to do is write something, okay, and you'll get full credit. If you don't write something, you get a 0. So you might want to start there because you get points. So how many points will the extra credit work? That's a really good question. So I will let you know is that's how I curve the test. So if you don't do it, it'll be really ugly for you. You hope it's worth 0 points. There's one situation where it's worth 0 points, and the hint is you hope. How come? Any thoughts? Yeah, it means you got 100% on everything else. And if you're complaining they're not giving you extra points after that, then you're just a complainer. 100%, you should be like celebrating and dancing and all that kind of stuff. Okay, so you hope that you don't get any, but the chance of not making any mistakes in the whole test is probability is pretty close to 0. Okay, so these are the things I want you to do. Basically, it tells you what you've done that works, how you can improve your studying habits in the class, and then what I have done that worked for you, and then what I can do to improve. This is your chance to give me feedback. Any questions at all on this test? This is the whole test. Again, there'll be more space for you. I want to mention a couple other things, and it's the rules of the test. Okay, so the rules of the test that I've already told you a bunch of times. See if anyone remembers. How long do you get? Let's see, there's some questions here. Yeah, 2 hours. Okay, unless you have a disability and you need accommodations, and then you get whatever they told me to give you. So do you want the extra credit to be detailed or just one sentence? One sentence is fine. Okay, don't spend all day on it, or you won't have time for the rest of the test. Do you have another meeting before the midterm? I might not. Depends on when you're taking it. I might be doing the next meeting on Wednesday, and then it's after the midterm. Depends what I hear from y'all. I'm definitely not meeting on Monday. How come? Yeah, Memorial Day weekend. So I try to, let you have a holiday. Okay, so I'm not meeting Monday. A lot of you are taking it Tuesday, so there's no chance that you'll have it before that. But I'll be checking the Q&A forum. And that's a good time to ask questions if you have any. So just some more notes about the rules. What do you bring to the test? What should you bring to your midterm? Yeah, bring your calculator. Bring a 3x5 note card with anything you want written on it on both sides. I recommend extra batteries because it would suck if your batteries went out, right? Pencil or pen, that's totally your choice. Okay, and that's it. Okay, if you want to bring a blank paper, you can, but it needs to be blank besides the 3x5 note card that can have writing on it. But you probably have enough. Yep, any kind of pen is fine. Okay, pens are good. Okay, eraser, I assume that your pencil has an eraser on it. But I don't recommend doing much erasing. It's better to lightly cross it out, because then if it was right, I could give you credit. And if it was wrong, I'll never take off points if you crossed it out. If it's erased, I'll never know what happened, and you can't get points. That's just a little suggestion for any test you take, not just my class. Okay, so those are the rules of the test. You're going to get 2 hours. I won't look at the test until Thursday, okay, and a week from Thursday. because I like to grade them all at once. So if you're taking it early, it won't be graded until after Thursday because I want to make sure that I can be consistent. And I'll grade them, and then I will post the key after I get them all returned to me to the midterm so that you actually can see what the right answers were, but not until after it's all over. Okay, so that's kind of what you should be doing for this test. A couple things just before the test, a couple things to make sure of. One is, a couple are obvious. Don't be hungry. Eat. Go to the bathroom. Okay, those are obvious, but you should do it. Statistically, what's the best thing you should do once you're not hungry and need the restroom, like the 20 minutes before the test? Any guess? They've done studies on this, statistical studies. So the 20 minutes before the test or so, even an hour before the test. Anyone know the best thing you can do? Okay, relax. That's good. Actually, they found out that's the second best in terms of meditation is what they call it. Review is one of the worst things you can do, it turns out. You got your note cards. You don't have to do like last minute memorization. The best thing you can do actually is light exercise. Yeah, go for a walk. Go for a walk. I used to throw a Frisbee around with a friend. Just something that helps you relax, but move you around because you can be sitting for 2 hours. So if you do a little bit of exercise, actually is good for your body. Is the exam online? Definitely not online. You're at a proctor center. It's paper and pencil. You're going to be writing a whole lot. And that's why I keep telling you, journal. Okay? One of the best study tools is actually the discussion forums, the assignments, because that's where I made you write a lot. Does that make sense? And in fact, those of you who didn't reply to the discussion forum that just got turned in last night, or finished last night, due last night, I put a note saying you better practice because you're going to have to do writing. This test has a lot of writing. Okay? So practice writing. Words that I want to be seeing are population mean, population proportion. Those are going to happen a lot on this test. And if you are referring to a population mean, but don't write the word population mean, I'll take off points. Same thing with population proportion. If you're referring to a sample mean, you need to write the word sample mean. If you're referring to the sample proportion, you need to write down the word sample proportion. So those are some key words. You need to have the word statistically significant or statistically insignificant. We did that today. You need to have things like with 95% confidence and then more stuff. Okay, there's a lot of words. And again, the discussion assignments are the best ways of looking at examples. Okay, because I give you a model. Any questions on that? So my warning was this was going to go longer, and I was right. It's the only one that actually, I think it's the only one that definitely goes past an hour and a half. And are you glad that I didn't like cut it off short and say, well, we're not going to review for the midterm? Because my goal is to get you prepared, help you understand what you need to do, what to expect. I recommend making sure you do multiples of each kind of the problems for this midterm shell. Okay, so practice writing this stuff out with a pencil and paper. Really important, because I want you to all do well. But if you don't practice, you won't do well. So I think we're about done. But as always, I can still answer any questions you might have. And I'll be checking the forums, on and off all day for the next, bunch of days. I don't have any major plans. I'm teaching here and there, but I'll be checking off, and I'm online a lot. I do sleep though. Are there any questions at all? Let me pause the share. Stop the share. There we go. There. Because now we'll get to the just last minute screen. But if there's any questions, I can answer them. If you have no questions, you can say goodnight because it's been a long one. Yeah, as long as you don't change it to after Wednesday, the test date, Brenda. A week from Wednesday. Okay, and if you said, oh, I changed it, I want to take it tonight, well, I haven't sent it yet, so don't do that. At least give me a day. Tomorrow, I'm probably going to start sending them out. Okay, so good night, Jacqueline and Zach and Constance and Ross. And happy to answer any other questions. Yeah, the date is a lot easier to change than the location, because once I've sent it, they've got it. Any other questions, Brenda or Bailey? Any questions, Brenda or Zach? You're still on? Okay, next week is fine as long as it's before, it's not later than next Wednesday for the test. Any last minute questions, Brenda? Your last one here? Otherwise, we can say goodnight. Okay, well then have a good night. And for all of you who are watching this as an archive webinar, thanks for watching. Do your best on the midterm, study hard, practice a lot of problems. You know what the problems are going to be somewhat like, do them. And I'll be happy to help you in any way. So post on the Q&A and I'll answer your questions. So have a wonderful evening.